Okay, this is coming from Unit 8, Lesson 3, Day 1 homework. This is question number 3. And in this one, we're asked to use algebraic reasoning and the inverse sine function to find solutions for each of the following equations. Give exact solutions in both radians and degrees if possible. So the first one starts off with the sine of x is equivalent to 1/2. Now I'm going to immediately jump to a special triangle here. This 1/2, 1/2, is ringing a bell. I know that the sine function is defined by the opposite side over the hypotenuse. So this is telling me that the angle x, perhaps this one, is equivalent to, the sine of the angle is equivalent to 1/2. The opposite side is over here at 1, and the hypotenuse here is 2. This is a special right triangle. When the shortest side is half the length of the hypotenuse, or equivalently if the hypotenuse is twice the length of the shortest side, then this right triangle is actually called a 30, 60, 90-degree right triangle. Or equivalently in radians, I could draw the same triangle out, letting this be 90, but 90 is actually pi over 2, right? And 30 degrees is pi over 6, 60 degrees is pi over 3. Now to help me remember where things go, remember this: the smallest angle is opposite to the smallest side. The largest angle is opposite to the longest side. And the angle in between here is opposite to, of course, the medium side length. So with this in mind, this is 1, this is 2. If you did a little Pythagorean theorem, simplified your radical, you could find that this is actually going to be equivalent to the square root of 3. Now that's actually equivalent beyond just 1. If you let this side be x, then the hypotenuse would be 2x, and the third side would be x square roots of 3. So they're all kind of tied to each other by a multiplier of the shortest side length. Now you could equivalently flip this around too and make this a 1 and make this half, and then make this square root of 3 over 2. But for the sake of this problem, it's just as easy for us to think about as 1, 2, and square root of 3. So if I get back now to the sine of x is equivalent to 1/2, I can actually look at my diagram and say, hey, 1/2 is the opposite side to this angle, 30 degrees. So I know my answer is x equals 30 degrees, or in radians, pi over 6. Now let's say I forgot about this over here and I did the inverse sine instead. If I did the inverse sine of 1/2, that would give me out x. If I'm doing that in terms of radians, I would get out a pretty nasty decimal. So I'm going to pull in my calculator here a minute and show you what I'm talking about. Okay, and so I'm going to go to calculate, and I should currently be in radian mode, but let's just check. Under doc, I'm going to go to settings and status, document settings, and go to the second one, and it says angles in radians. So we're going to leave that way. I'm going to hit escape. So what I want to do is actually go to trig now, inverse sine, and put in there 0.5 or a half. Look what I get out, 0.523599. Well, that is a radian measure, but the question also says to give exact solutions. Exact solutions do not necessarily imply terminating decimal. They imply some kind of rational function or some sort of non-decimal piece. So I have to recognize that 0.523599 is some kind of nice exact value. You might not. That's why I jumped into the right triangle equivalency instead. Being a special right triangle, we can see that it's an exact value. Now let's just say you saw this number and you're like slightly reminded. You're like, hey, I think that 0.52359 could be special. Check it by dividing by pi. If you divide by pi, it might actually unveil a decimal that you do recognize. 0.166 repeating is 1/6. Okay, and don't believe me, I'll turn the number over here into a fraction, and we actually can see that sure enough it is 1/6. So that way I know this answer of 0.523599 is actually 1/6 of pi, or pi over 6. Now one way to avoid the problem of the decimal, and you think it might be a good exact value, you can actually turn your settings and status into being in degree mode instead. And if you're in degree mode to start, now to keep this way I have to say make default, but that's okay. Then if I do the inverse sine or arc sine of 0.5 in degree mode, now it gives me a nice 30-degree measure. 30 degrees then can be converted easily into radians as well. At some point in time, though, all these different connections need to come together to say that we recognize that 1/6 is 0.16 repeating, or that 0.52399 is our pi over 6 value. I think it's best to really just look at that special right triangle. Avoid using this if you know what the ratios are. So I'm going to get back to the ratios. Okay? And I knew that the inverse sine of 1/2 was equal to 30 degrees or pi over 6. Now let's equivalently do part B. This one actually is a little bit different. It says that the sine of 3x is equivalent to 1/2. When you see an expression like this 3x is actually inside of the sine function. So do not try to divide by 3 first. You have to actually get to the 3x by undoing sine, which is why we study the inverse sine. Inverse sine and sine will cancel each other out as inverses, undo each other, if you will. So the input becomes the output. If I write that out, it looks something like the inverse sine of the sine of 3x equals the inverse sine of 1/2. As I was saying, the inverse sine and the sine would cancel. 3x would be the output. Inverse sine of 1/2, if I reference my first answer in part A, I know this to be pi over 6, or I know this to be equivalent to 30 degrees. So I'm actually write two expressions. 3x equals pi over 6, or 3x equals 30. One's in degrees, one's in radians. So my last step then would be divide by 3 here, and divide by 3 here. Now pi over 6 divided by 3. It looks pretty gross, but dividing by 3 is the same as multiplying by 1/3. So I could also say that this is equivalent to pi over 6 times 1/3, which is pi over 18. Over here, dividing by 3, 30 divided by 3 yields that x is equal to 10. So I either have pi over 18 in radians, or I have 10 degrees as a solution. So that's part A and part B. Let's look at C. C gets a little more complicated. We add a few more parameters. We have 8 sine of 0.4x minus 1 is equivalent to 3. So again, I can't get to the center of this until I isolate it by undoing some of the algebra that's here. So I'm going to take care of the subtract 1 first. The subtract 1 is not inside of the 0.4x. How do I know that? Well, if it were, mathematicians will use parenthesis sets. So put parenthesis around the 0.04x and around the -1. So I don't have the parenthesis set here, so I know that that -1 is not inside, or the subtract 1 is not inside of this operation. So we'll add 1 first. This yields 8 sine of 0.4x equals 4. Then we'll divide by 8, which yields sine of 0.4x equals 4 over 8 is 1/2, or 0.5. At this point in time, I want to get to the 0.4 that's inside of the expression, so we'll do the same arc sine as the last problem we did, but I'm not going to write out the full expression. I'm going to do a little bit of shortcut here. I know that 0.4x is equivalent to the inverse sine, or arc sine of 1/2. Now the arc sine of 1/2 I already know the answer to. The arc sine of 1/2 is 30 degrees, or pi over 6. That's equivalent to 0.4x. So we'll again make two different expressions here. Let 0.4x equal 30, or let 0.4x equal pi over 6. So I have to divide by 0.4 on both sides of this. Now if I want to keep exact, remember that 0.4 is 4/10. Dividing by 4/10 is the same as multiplying by its reciprocal of 10/4. So this is equivalent to the multiplying by 30 times 10 all over 4, or 300 divided by 4. I could do a little bit of simplifying in this if I wanted to. 10/4 is also the same as 5/2, so I could have 5 times 30, which makes 5 times 3 being 150. So this would be 150 over 2, or this being 75. Okay, 75 degrees. Equivalently, we could also write this as pi over 6 divided by 0.4, and so if we write it this way, we have to do the same division, so I could write this as pi over 6 times, I'm going to write this one a little simpler, maybe it will be simpler, as multiplying by 5/2, which will become 5 pi over 12. So those are my two answers, 75 degrees or 5 pi over 12 radians. That ends day 1 homework.